Okay, I think before I go into charging and discharging of cells, of lithium iron phosphate cells, batteries, I think it should be discussed about the degradation and lithium plating and dendrite growth that can happen in your batteries. Now, I don't really understand why they say it's lithium plating, because I I think it's more lithium deposits that happen on the anode, which is the negative electrode. Now this I have to try to keep catching myself because I'm used to cathode being negative, not anode being negative, but the way they word it here and how the engineers or whatever developed these batteries, they went with the anode being the copper current collector and the cathode being the positive current collector, and it's aluminum. Not sure why they did that. I'm sure they have their reasons. So we'll go into a little bit of theory here. On the aluminum electrode, the positive one, the cathode, it has your lithium, your iron, your phosphate. So under a totally discharged conditions, before it's ever charged, that's the state of the battery. On the positive side, with the copper electrode and the anode, this has graphene attached to the current collector. Flakes of graphene. They say graphite, but I think it's graphene myself. So during the charging process, the electrolyte has lithium ions in it, and the negative side, or the positive side, has lithium ions and iron and phosphate that bind it together. During charging, they come from the positive side and they go to the negative side. So if all conditions are proper, there's no problem. But I want to talk about the conditions. So unfortunately, I don't have a table that shows charging with temperature. This is actually showing discharge curves under different temperatures. And it's showing that minus 20C, your discharge curve is very low. This is a test environment using a 20 amp hour battery. So this is a 20 amp hour reference. This is supposedly from 100% state of charge, and this is showing the different temperatures. So if you look right here at minus 20, you hardly get any energy out of this battery. Whereas I think it's 20 centimeters or 20 Celsius, you get the best. You get your 20 amp hours and maybe a little bit more. But when it goes up to 60 Celsius, it drops down some because it's too hot. The cell gets too hot. So when you listen to people and they say that you want to try to keep the batteries at room temperature, that's what you want to try to do. You want to try to charge or discharge your batteries at room temperature. Now, looking at this and looking at -20, you should never charge your batteries below 0 Celsius, and that would be 32 Fahrenheit. Because what happens is, the colder the battery gets, the harder it is for the lithium ions to move in the electrolyte and go through the separator. So I have a bigger sheet here that'll show. Let's maybe upside down here compared to what I was showing before. So what happens is, if it's colder, the lithium ions come through the separator, and the graphene is tighter, and it's a thicker. It gets thicker when it's colder, and what happens is, it can't penetrate and get into the graphene to deposit the ions. And sometimes, it's like it says, it deposits or plates the outer edge of your collector. And that's one way of forming lithium plating. Again, I think it says right there, it says lithium plating and dendrite growth. So there's two ways of doing it. The cell is too cold when you charge it, or you're charging it too fast. In other words, if you have a 100 amp hour battery and you want to charge it real fast, and you want to put it on a 50 amp hour charger so you'll charge it in 2 hours, that's bad. Because that's trying to force the lithium ions in the graphene too fast, and they don't have time to spread out and find a place to go. That's the easiest way I can explain it. That they can't find a place to go, they just get bunched up, and that is how you get plating. So it's charging too fast, too many amps, or too high a voltage, which, if you're using the right charger, you shouldn't be too high of a voltage. But I guess that all depends on whether you're trying to charge a 12-volt battery with a 24-volt system from a solar panel. Obviously, if you're doing something like that, you're definitely going to be in trouble. But this is the main thing. Cold, try to charge at room temperature, or as close as you can be. That's the best for your batteries. Try not to use too much current. Don't try to charge your batteries too fast. I charge mine at 10 amp or 20 amps, which takes 5 hours plus to charge my batteries. My batteries don't get too hot. They seem to work out fine that way. I don't think that's too high of a current, and I don't think I'm having a problem. So that's the main key things, is temperature and rate of charge. So that's mainly what I want to stress on this video, and I wanted to show what happens. Because when you form the lithium ions and you start depositing them or plating them, then they start stacking up every time you charge. They'll go right to that point. And that's how they have dendrite growth. And then they just get further and further and further. And what'll happen is they'll puncture the separator. And the separator is what's separating the positive from the negative. And if you puncture that, you're going to get a short. And if you get a short, you could have your battery go either be ruined, or worst case scenario, it'll short out and go into thermal runaway, and then you're in trouble. Because we've all seen those videos. So the key thing is temperature and rate of charge. I hope I hope people will see this video and understand, well, I guess it's here, understand on charging that you can plate with lithium and you can get dendrite growth. Thanks.